Hello everyone, myself Govind Vittal Thomre. I am working as assistant professor in the Department of Mechanical Engineering. Since last 10 years, I am working with the Fulton Education Society's College of Engineering, Fulton, and with the mechanical department. Today, we are going to see uh, the Mechanical Lab 3 and the first experiment of the Machine Design Practice 1. So here in the Machine Design Practice 1, there are three practicals are there. First one is a design report, the giving necessary calculations of the design components and assembly. And the same in the second practical, we need to draw this design on the A3 size sheet as assembly and the different components. And third part is to at least two assignments on the same need to draw. So as talking about regarding a first uh, practical is a design report giving all necessary calculations for the design components and assembly should be submitted with the separate files. For this we have taken the knuckle joint. So basically for the knuckle joint we have three components in that. First you can see here eye, second is a fork, and third one is a pin. So this is the three components, and you can see the assembly of the three. Here are the different dimensions are given here. Now we can see this knuckle joint in a static condition. Force P is applied on the both the side, so on the fork and on the eye, and pin is giving assemble this both components. You can see the top view here. So there are different dimensions you can see. So what is the design procedures for the knuckle joint? As we know that first we need to calculate the diameter of the each rod. As I said, P is the force applied on the both the side, as on the fork and as on the our eye. So here we can see that the tensile stress is failure criteria we consider, and this total force P on the fork is divided into two parts. There is a P by 2, P by 2. So on the each component you can see the total force is a 0 on the left side and on the right side. Similarly for the each component it is done, and with this we got the relationship D is equal to square root of 4P divided by pi into sigma T, where the T is the diameter of the each rod, P is a tensile force, and sigma T is a permissible tensile stress. Second, calculate the enlarged diameter of the each rod. So we have a empirical relationship. So whatever the enlarged areas is here, right? So D1 is equal to 1.1 times D, and from this we can find out the enlarged diameter of the each rod. So where D is the diameter of the each rod and D1 is the enlarged diameter. Third is the calculation of the dimensions A and B. Here A and B, what is A is the thickness of the each eye of fork. So this is the thickness each eye of the fork, this thickness, and this thickness is A. And B is the thickness of the eye end of the rod B. So this is the thickness B, the eye end of the rod B. So the empirical relationships are here. A is equal to 0.75 times D, it is the diameter of the rod, and B is the 1.25 times of the D. So this is the diameter of the rod, and here this is the B. Fourth one, calculate the diameter of the pin. Now while calculating the diameter of the pin, here two criteria are there, failure criteria. First one is a shearing and second one is a bending. As we know that the forces are given here. So shearing, by considering the shearing failure, here the first relation we got to find out the diameter of the pin is a D is equal to square root of 2 times force applied on the rod divided by pi into tau. Tau is the permissible shear stress for the given material. And for the bending stress is given here. So from this we got the relationship D is equal to cube root of 32 divided by pi sigma b into p by 2 in square bracket b by 4 plus a by 3. So this two relationship we got, and whatever the largest value we got from this two relationship, we will take this as a diameter of the pin, or we will select as a diameter of the pin. Fifth one is calculation of the dimensions D0 and D1, where D0 is the outside diameter of the eye fork and D1 is the diameter of the pin head. So by selecting this, we will use the crushing stress, that is a sigma c. Sixth step is to check the tensile, crushing and shear stresses in an eye, and these formulas are given. So by putting the values, we have to check for the eye whether all stresses are within a limit or not. Similarly, for the seventh step, check the tensile, crushing and shear stresses in the fork. We have these formulas, and by using this we will use these formulas to check the stresses are within a limit or not. So this is the steps, and now we will take the actual example of the knuckle joint. So here is the example. It is required to design a knuckle joint to connect the two circular rods subject to the axial tensile force of 50 kN. The rods are coaxial and small amount of the angular moment between their axes is permissible. Design the joint and specify the dimensions of its components. Select the suitable material for the parts. So as only force is known quantity here, the given data is a 50 kN force is given. Now first step is the selection of the material. As we know that this is a rod subjected with the tensile force, therefore yield strength is the criteria of the selection of the material rods. So here we can say that the pin is subjected to the shear stress and bending stresses. The strength is also criteria for the material selection of the pin. So on the strength basis, the material of the two rods and pin is selected as a plain carbon steel of the grade 30C8, whose yield strength is 400 Newton per mm square. It is further assumed that the yield strength is in a compression is equal to yield strength in tension. So in practice we know that the compressive strength of this steel is much higher than the tensile strength. Second step is selection of the factor of safety. As in a stress analysis, the knuckle joint, the effect of stress concentration is neglected. To account for this effect, a higher factor of safety 5 is assumed. Third step, the calculation of the permissible stresses, where tensile stress, then crushing stress and the shear stress is calculated by putting the values here in these equations. Fourth one, now calculation of the different dimensions. As we have seen the procedure, first of all, diameter of the rod we need to calculate. So its formula is a square root of the 4 times force applied on the rod divided by pi into permissible tensile stress. So the value of the diameter is coming 28.21, but we approximate it to the next value is 30 mm because standard shafts rods are available in a 30 mm. Then enlarged diameter is the second dimension, that is a di, 1.1 times of the rod diameter. So we got the 33, we make it as 35 as a standard. Then dimension of the A and B, as we know that the thickness on the eye fork we given, and B is the thickness of the eye end is given. Then these two values, A is at 25 and B is 40 mm. Then diameter of the pin we calculate by the two, as we discussed above, two methods, that is by the shearing and by the bending. So by these two formula, by the shearing criteria we got the 30 mm diameter, and by the bending moment or bending as a failure criteria we got a 40 mm. So larger value from the both we need to take. So here we have taken the 40 mm diameter as a pin diameter. Through the empirical relationship, D0 is equal to 2 times D. So 80 mm is coming here, and D1 is the 1.5 times of the D. So this value is 60 mm here. Now for the check for the stresses in an eye as discussed previously. So tensile stress is a 31.25, which is a less than 80 Newton per mm square. Crushing stress is also 31.25 Newton per mm square, and it's a less than 80 Newton per mm square. It is also safe. If we are checking for the shearing stress in an eye, so it is coming 31.25, which is a less than 40 Newton per mm square. Seventh is the last step is the check for the stresses in a fork. So tensile stress is coming at 25 Newton per mm square, which is a less than 80 Newton per mm square, which is safe. The crushing stress is also coming as same 25 Newton per mm square, which is a less than 80 Newton per mm square, which is safe. Finally, the shearing stress is coming on the fork is 25 Newton per mm square, which is also less than 40 Newton per mm square, which is safe. So if we are checking all the dimensions, whatever we got is safe as per the whatever the given failure criteria for the eye and fork. So final dimensions here, rod diameter is 30 mm, enlarged rod diameter is 35 mm, fork thickness is 25 mm, eye thickness is 40 mm, pin diameter is 40 mm we got here, outside diameter of the eye or fork is 80 mm, then pin head diameter is 60 mm. So all stresses are within a permissible limit and the design is safe and satisfactory. So where we are using this knuckle joint, we are using the knuckle joint in a mechanical linkages used in a wall system, levers and bicycle brakes. In automotive, we are using knuckle joint, steering tie rods, suspension components. In aircraft as well, we are using the control cables and leading gear linkages. In a cranes and excavators as well, to load bearing joints in a booms and hooks, we are using a knuckle joint. In a railways coupler between the rail cars, we are using a knuckle joint. In marine, rubber assemblies towing a system where we are using knuckle joints. Industrial machines, conveyors, presses and tensioners where we are using a knuckle joint. So this is our first practical where we need to prepare the report of design of any of the machine components, and this is a knuckle joint as I have explained the different aspects. Okay, and we have seen the procedure, and with the example we have seen how the knuckle joint is designed. So all the design aspects we have seen. Thank you so much. Thanks.